With iCloud, when you make a change on one device, it instantly updates all your others. Download an app on the go, and it's there when you get home. Along with some other stuff you didn't order. Make a change on the way to work, and get immediate results. Take a shot of this, and you get a whole lot more. Now, the things you do on your phone have an impact on the world. Apple powers its iCloud with dirty energy. Tell them to think differently.
Hello, my name is Eric Schaefer. I will be your host on this episode. Today we'll be discussing what acid rain is. We're wondering if it's a form of liquid, gas, solid, or even energy. What is it? Let's ask and talk to an expert, Jessica Carter.
Hi, acid rain is rain with an acidic or low pH compared to water's natural pH.
What causes acid rain?
It is caused by pollution from cities, cars, even plants and volcanoes.
Why is this a big deal? Acid rain does not affect us. And you can even drink it, so why is it a problem?
It does in fact affect us by eroding buildings and statues. But it primarily affects our surroundings.
This and more on this episode of SJS Science Now. Acid rain is formed from clouds which hold a combination of water, vapor, and vapor from atmospheric pollution. The pollution is caused by man-made production of man-made resources that we use today, like electricity, cars, batteries, and hair dryer. It is also caused by natural stuff like plants and even volcanoes. These are all examples. Pollution is created when coal or oil and other chemicals are burned. Here is an expert on this subject.
Acid rain is rain with a pH below 5.6 and can be found as low as 4 in the northeastern parts of the United States of America, like Maryland, Rhode Island, and Maine. It is there because the wind blows pollution there from different places and it mixes it with the rain. It is like a junkyard where all pollutions meet from the different states.
We know the pollution can be caused by the burning of coal and oil, but what are some additional chemicals that cause pollution? I went down to a school in Sheridan to get help. Here's Camille, maybe she can help. Can you tell me some of the causes of pollution?
Sure. Sulfur dioxide and nitrogen oxide are common causes of pollution.
So we know what pollution is and the change in rain pH so that it causes, but so what's the pH of regular rain?
Well, regular rain has a pH of a little under 7.
How about the water we drink?
The water we drink is about the same, sometimes with a slightly higher pH.
If living creatures can drink acid rain and it's not harmful to our skin, why is it such a big deal?
Well, acid rain can slowly destroy ecosystems like forests and bodies of water. The change in pH that acid rain causes in lakes or oceans is very difficult for marine animals such as fish and turtles to adapt to. Human skin can handle acid rain, but skin of more delicate creatures like fish and slugs cannot. illness in humans, as well as the slow killing of our surroundings.
The government tried to prevent acid rain, but they made it worse. In the 19th century, a law was passed forbidding the construction of short-stage or smokestacks. You can't see it, it isn't there.
Pollution a person makes a day, and how many people are on Earth. But there are no exact answers.
So now we know Earth has acid rain, but how about
Venus is the only other planet that we know that has acid rain. Acid rain there is even lower pH than the acid rain found on Earth. So it would have painful burning effects for us if we were to experience it. This is because on Venus is like a greenhouse. It is very hot.
To review, acid rain is rain with pollution inside primarily sulfur dioxide and nitrogen. Acid rain has a pH lower than 5.6, whereas regular rain is a little under 7. This is a big deal because although it doesn't affect humans significantly, it severely affects our surroundings. Thanks for watching!
As the world continues to seek alternatives to fossil fuels, many products have been evaluated, but few are as efficient to produce as palm oil biodiesel. Combined with an extraordinarily low environmental impact, palm oil is a sustainable, renewable biofuel that is hard to beat. Palm oil uses less land, energy, and fertilizer than other comparable crops, but amazingly is able to generate nearly 10 times the amount of energy it consumes. In comparison, products such as soybeans and rapeseed oil cannot generate more than 3 times the energy invested in production. As a result, palm oil is by far the most energy-efficient oilseed product available. This has led to significant industrial investment in palm oil as a biofuel. When it comes to U.S. acceptance of palm oil biodiesel as a renewable fuel, however, the market has suffered due to inaccurate emissions conclusions. As per U.S. Environmental Protection Agency rules, only biodiesel that saves 20% or more on emissions when compared to conventional fuels can meet the renewable fuel standard. According to the EPA, palm oil only provides a 17% savings. A study conducted by Neste Oil, however, has found that greenhouse gas emissions from palm oil can actually be 47% lower than conventional fuels. Other studies have found that palm oil can actually provide over 60% reductions, which can be increased to over 70% when coupled with methane capture technology.
This is the fast track to more jobs and America's energy independence. Advanced performance is here, now. Biodiesel, America's advanced biofuel.
Hello, I'm Christian Lindsay, your host on SJS Science Now. On this episode, we will investigate if biodiesel can solve the energy crisis, and what would happen if we ran out of fossil fuels, which power our homes, deliver our food, and transport our merchandise. If fossil fuels were to run out, we would be required to find an alternative fuel. In this episode, we will see if biodiesel can be that alternative. All of this and more on this episode of SJS Science Now. Making biodiesel is simple. It can be made in a science lab like the one I'm in a full-scale factory, or even in your backyard. I'm going to be investigating 3 different methods of producing biodiesel. The first will be performed in the lab by the students at the Sheridan Japanese School. We will then talk with the scientist who makes it in his own backyard, and finally to the people who produce it commercially. First, let's talk about the basic process required to make biodiesel, which holds true for all 3 ways of producing it. The ingredients and materials for this process can be purchased at your local grocery store. During the production of biodiesel, a chemical process called transesterification takes place, in which ordinary oil becomes a high-energy burnable fuel. The first of these 3 ways we will be examining is in the lab, when we mix catalyst, lysol, and ethanol and this will be our final product. If we decide to make biodiesel on a large scale, making it in labs would not be practical. To figure out how it would be made on a large scale, I went to a factory in Salem called Sequential Biofuels. At Sequential Biofuels, how much biodiesel do we produce each year?
We produce about 6 million gallons of biodiesel every year, and that biodiesel goes into cars. It gets used for home heating oil, and it also gets used in boilers and a lot of other applications.
Vehicles. Do you get better mileage with biodiesel or fossil fuel?
Biodiesel behaves almost exactly like regular diesel. So whatever mileage you get in your vehicle, you're going to get the same with biodiesel as you are with regular diesel. There's very little energy loss, so little that you can't even tell.
How many vehicles do you think biodiesel needs?
Well, 5% of all the diesel that's sold in the state of Oregon is biodiesel. So my best guess is thousands of vehicles use our biodiesel every day.
Do you have safety systems for accidental spills?
Absolutely. To have a company like this and to have as many people working here as we do around the chemicals that we use, we have to have a very rigorous safety program in place. So everyone that works here is trained on how to handle the chemicals properly, how to drive things like forklifts, and how to be safe overall when it comes to spills, when it comes to heavy lifting, and it comes to interacting with these chemicals. So we have a very, very good safety program in place, and so far we've been relatively safe, except for that.
How clean does biodiesel burn?
Well, there's many categories of emissions from a tailpipe. But if you're running 100% biodiesel in your car, it burns about 70% cleaner than regular diesel does.
Do you think biodiesel can solve the energy crisis?
Biodiesel can play a big role in helping reduce our dependency on oil, but it can't solve it on its own. There has to be a combination of all kinds of renewable energies if we're going to be able to replace oil. It has to be biodiesel, wind, hydro, solar. It has to be a combination of a lot of things, but biodiesel won't be able to do it on its own.
Do you think biodiesel and fossil fuels could survive another 1,000 years?
I don't think they can. Not another 1,000 years. If you look at a lot of studies and statistics about how fast we're consuming petroleum, we're within a couple hundred years at this point. And even though biodiesel is a renewable fuel, there's only so much that you can make. There's only so much vegetable oil in the world.
How long do you have an estimation of biodiesel?
How long will we be able to use it? I'd say, that depends. We have to increase engine efficiency. So the more miles you can get out of a gallon of biodiesel, the longer we're going to be able to extend its life. We also have to make sure that we can continue to grow crops for cooking oil that we can use for food and then in turn use for biodiesel. So it's a sustainable crop, but there's a lot of things that come into play with forecasting how long it's going to be sustainable and a viable option.
Does biodiesel in any way erode an engine?
That's an excellent question. In older engines, 1980 or earlier, depending on the model, they use natural rubber, and biodiesel does have a higher lubricity, but it's also it's a solvent as well, so it will break down natural rubbers, but any newer model car is going to use Viton instead of natural rubber, and biodiesel holds up very well against, or Viton holds up very well against biodiesel, so it doesn't really do much to the engine at all.
How do you power your factory?
Well, we use a lot of electricity. We also have boilers that we run on fuel that we make ourselves. So steam is a big part of what we do. And we have a pretty big solar array. A lot of solar panels help offset the electricity that we need to run this place. So we power it in an array of ways.
However, most people cannot simply purchase factory-produced biodiesel, which is used often as a gasoline additive, or create their own in a laboratory. For this reason, the majority of straight biodiesel users are known to create their own at home. Hi, I'm with SJS Science Now. Is it okay if we ask you a couple questions? Sure. What made you want to produce your own biodiesel? What are some pros and cons of making biodiesel?
Some pros are, it's very cost effective, and there's not that many carbon monoxide emissions. And I get to use something that would go to a landfill. But it takes about 10 hours to make a 40-gallon batch.
What do you do with the leftover glycerin? How do you dispose of it? And now a parting thought. Many people hold the misconception that fossil fuels will last forever, or at least not run out during our lifetimes. They are wrong, however. The truth is that by 2060, we will likely run out of affordable crude oil. This is a threat of apocalyptic proportions. Crude oil literally powers civilization. Without it, there would be no functioning grocery stores, mail, or vehicles. The world as we know it would collapse. This is why an alternative fuel source is so critically important. Thanks for watching.
I'm against nuclear power because I care about my children. But maybe then I should be for it, because they'll need energy too, and fossil fuels in 50 years' time, there won't be any left. There are renewable energies, but will that be enough? In the meantime, with them, there's no waste, but nuclear power. That said, the quantity of really radioactive waste isn't that big, a thimble per year per person. Multiplied by the number of people, that's a pretty big thimble. There are solutions, although storing them. But at least then we know where they are, because the CO2 produced by oil and coal, hello greenhouse effect. On the other hand, there's the risk with the power plants. Although in matters of safety, there's no place more safe. In the end, nuclear energy is a source of problems, and at the same time, it's a source of solutions.
And you? Are you for or against nuclear energy? Or don't you use electricity?
Every day, we use radiation to take x-rays, treat cancer, identify elements in museum pieces and crime scenes, date ancient artifacts, and trace medicines inside the body.
What is nuclear radiation? The future of energy? An unrelenting force of destruction? Or both? The answer, here on SJS Science Now. We are warmed every day by an unimaginably huge burning ball of gas 93 million miles away. From this source of heat and light that we know as our sun, ultraviolet and infrared rays are emitted. While infrared rays are long, with low energy and fairly harmless, ultraviolet rays are short, with high energy and can be very dangerous. They are known for causing skin cancer. These rays are both radioactive.
What exactly is radioactivity?
It is a process in which unstable atomic nuclei become stable. When this process takes place, three types of rays called alpha, beta, and gamma rays are emitted.
So if they all come from the same source, what is the difference?
Alpha particles are positively charged, while beta particles are negatively charged, and gamma particles have no charge at all. Additionally, these three types of rays have different levels of strength. If you were to send these rays through an obstacle course on which they must travel through different substances, alpha rays would have to drop out the race due to deflection by paper. As beta and gamma proceed, beta will find itself being deflected by wood, leaving gamma as the winner, deflected by stronger substances such as lead and concrete.
You may be wondering if these nuclear atoms are stable or safe in nature. The stability of the atom depends on its neutron to proton ratio. A proton is a subatomic particle found in all atomic nuclei, with a positive electron charge, and a neutron is a subatomic particle with no electric charge. The ratio between these two particles is important because it determines whether or not the atom is stable. If there are too many neutrons, the protons are not able to keep the neutrons in the electron cloud, and they are emitted off as beta particles. If there are too many neutrons, the protons are not held in the electron cloud, and they are emitted as a proton. The rate at which these particles are emitted is known as the half-life of an atom. The half-life is the time required for 1/2 of the atom's radiation to be emitted and to decay to half its original size. To understand, let's look at uranium-238. After 4.5 million years, it turns into thorium-234 and gives off alpha particles. In 25 days, it is then protactinium-234 and gives off both beta particles and gamma rays. This then goes through 11 other unstable isotopes until it reaches lead-206, the resulting stable isotope. Think of it like bread soaking in water. If the bread is in there for a long period of time, the particles will become saturated and it will split apart. Eventually, those smaller pieces are going to split apart until there's nothing left to split. To take a look at what powers our nuclear reactors, we need to define two key terms, fission and fusion. Nuclear fission is the splitting of a nucleus into smaller fragments, accomplished by the release of neutrons and a large amount of energy. Nuclear fusion is the joining of two smaller nuclei to produce one heavier nucleus, accomplished by a release of a large amount of energy. This is what we find in a nuclear power plant. Fusion can be modeled by taking two different bubbles and merging them together to create one large superbubble. Fission is the reverse of fusion. If you were to pull those two merged bubbles apart, you would have fission. We were able to interview a scientist about radiation and how much the average American gets in 1 year.
Many people all over the world are afraid of radiation, but the average person in the United States gets about 360 milliram per year, which doesn't have a significant effect on the body.
You are being exposed to natural background radiation. There's nothing out here. We could not perform these tours with it. If you have ever been in Spokane, you have received 3 times more radiation than you are in the Tri-Cities because of the uranium ore in the ground. If you go to states like Montana or Wyoming or New Mexico, it goes up even higher. The Earth itself is radioactive, and it depends on where you live, the amount of that radioactivity. If you've ever eaten a banana, anybody? You have eaten radioactive material. A banana is radioactive. Have you ever seen a smoke detector in your home? The only way that can work is there's a radioactive source inside of it. We live every day with radioactivity. Every day. Yep.
There are several ways for people to detect all of this radiation. The three primary methods to do this are using the Geiger counter, the scintillation counter, and the film badge. The Geiger counter is a gas-filled metal tube which is used to detect the presence of beta radiation. A scintillation counter is a device which utilizes a surface coated with phosphor. Ionization strikes the phosphor surface and produces a light. The film badge is a small radiation detector and can be worn on the body. It is usually worn by people working near radiation sources. It consists of several layers of photographic film covered with black, light-proof paper enclosed in a plastic or metal container. Radioactivity is used by people in the medical field as well. Radioisotopes are used in tracers which can identify abnormal body processes and are helpful in diagnosing diseases. Radiation can be used in the medical field for cancer treatment as well as X-rays and MRI machines. Our team took a trip to Hanford to see the nuclear reactor. Good morning! It is April 16th? 17th, right. And we are about to leave for Hanford to see the B reactor.
The timeline for this thing to come operational was unbelievable. In September of 1944, they were putting fuel in it and starting to get it started. By December of 1944, they were producing the first amounts of plutonium and sending them to Los Alamos, which was another part of the Manhattan Project, to actually develop a plutonium bomb. You see these valve covers that are open. This is a result of treaties we signed with the Russians in the late 90s not to produce any more plutonium.
If we would utilize a different plutonium in the battery for an automobile, you could drive for 20 years without refueling that car.
Although often deemed dangerous due to past experience with nuclear explosions, nuclear power plants are incapable of exploding because fusion is the cause of explosions, and nuclear fission is what takes place in nuclear power plants. While there is danger in waste material contaminating the environment as it decomposes over several years, this is a preventable danger. Nuclear energy, therefore, can be one of the cleaner energy sources because of its minimal combustion. By combining the use of nuclear energy and biodiesel, we can help prevent acid rain.
She's using more. He's using more. We're all using more electricity. America's appetite for energy is growing. So, how do we generate more electricity that is cleaner, safer, and made here in America? Part of the answer is nuclear energy. Nuclear energy facilities in 31 states already provide electricity 24/7 for 1 in 5 homes and businesses. And nuclear energy is America's largest source of clean air electricity. With production costs at about 2 cents per kilowatt hour, it's affordable, reliable, and ready to meet our growing energy needs. Nuclear plant safety is a top priority. Above all, the men and women who work at these facilities are committed to making safe nuclear energy even safer. So, nuclear energy can provide made-in-America electricity while protecting the environment. Nuclear, clean air energy.